What's shaping up to be one of the most intriguing winter weather setups we've seen in recent weeks. Significant model disagreements for next weekend's potential winter storm, particularly across the southeast and mid-Atlantic. We're going to break down the central U.S. implications first, then dive deep into the eastern U.S. scenario, and then geek out about the atmospheric dynamics that are making this such a challenging forecast. Let me be clear about something right off the bat. We're looking at a time frame that's just now entering day 7, so this is not some distant fantasy storm we're tracking 10 days out. This is real energy that models are beginning to lock onto, but we're still trying to iron out critical details. The European model and the GFS are showing two somewhat different solutions, and I think the truth will probably be somewhere in between. So let's start with what we know with high confidence. We have winter storm watches that have already been posted, extending from portions of Texas, transitioning through Oklahoma, Arkansas, and into the lower Mississippi Valley. These watches stretch all the way from San Antonio northward through Dallas-Fort Worth, Oklahoma City, Little Rock, Memphis, and Nashville. The National Weather Service is already getting ahead of this, which tells you they're seeing consistent enough signals to start alerting the public. Now, the first question you're probably asking is, what type of precipitation are we talking about? And here's where it gets interesting. We're dealing with a complex setup that's going to involve multiple precipitation types across different regions. Blue is snow, pink is freezing rain, orange is sleet. I'm going to repeat that several times as we go through this because it's critical to understanding what each area might see. Let's start with Texas and work our way eastward. Dallas-Fort Worth. You're looking at precipitation beginning Friday evening, probably around 6 p.m. This is going to start as snow initially because we'll have cold air in place at the surface. But here's the thing that makes this tricky. We're going to develop what meteorologists call a warm nose in the atmosphere. That's a layer of above freezing air sandwiched between cold air at the surface and cold air aloft. What that means practically is that snow falling from the clouds is going to melt as it passes through that warm layer, then refreeze as it falls back into the cold air near the ground. That gives you sleet, or ice pellets if you want to be technical about it. By midnight Friday into early Saturday morning, Dallas-Fort Worth transitions from snow to sleet and freezing rain. The European model keeps this going through Sunday morning with periodic heavy bursts. The GFS is drier and faster, wrapping things up by Saturday evening. For Fort Worth specifically, same timeline. Waco, Tyler, and Longview. You're all in this zone where it begins Friday evening as snow, transitions to mixed precipitation overnight. Now, let's talk about the accumulations the models are suggesting. And remember, these are not forecasts yet. The European model is showing potential for 1/4 to 1/2 inch of ice accumulation across the Dallas Metroplex. That's in the range where you start seeing significant tree damage and widespread power outages. The GFS is more conservative, showing closer to 0.15 to 0.25 inches. That's still enough to make roads extremely dangerous, but probably not quite as catastrophic for the power grid. Moving into Oklahoma. Oklahoma City, you're on a very similar timeline. Precipitation begins Friday evening, starts as snow, transitions to sleet and freezing rain by late Friday night. Tulsa, Norman, Lawton, you're all in the same boat. What's fascinating about the Oklahoma setup is that you might actually stay cold enough at the surface in some locations to see mostly sleet rather than freezing rain. That's actually the better scenario because sleet doesn't stick to power lines and tree branches the way freezing rain does. Arkansas is where things get really interesting from a meteorological standpoint. Little Rock, Fort Smith, Fayetteville, Jonesboro, Pine Bluff, you're all looking at Friday evening into Saturday as the main event. But here's what makes Arkansas tricky in this setup. You're right in the transition zone between the colder air to the north and the warmer air trying to surge northward from the Gulf. Little Rock specifically could see this begin as snow Friday evening, transition to sleet, then to freezing rain by Saturday morning, and potentially even transition to plain rain by Saturday afternoon if the warm air wins the battle. Or you could stay cold enough to see freezing rain the entire time. That 20 to 30 mile difference in where the warm air boundary sets up makes the difference between 1/2 inch of ice and just some sleet. Let's shift to Louisiana. Shreveport, Monroe, you're definitely in play for this. Starting Friday night into Saturday morning, mostly freezing rain is what the models are suggesting. Baton Rouge, New Orleans, Lafayette, Alexandria, You're probably going to be too warm for anything frozen, but you'll see heavy rain as this system moves through. The GFS is trying to generate some light snow along the immediate Gulf Coast Saturday morning, which would be absolutely wild if it verified, but I'm not fully convinced by that solution. Mississippi needs to pay close attention to this. Jackson, Gulfport, Hattiesburg, Tupelo, Meridian. The models are showing a significant ice event for the northern half of the state. Jackson specifically looks like Friday night into Saturday with freezing rain as the primary precipitation type. We could easily be talking about 0.3 to 0.5 inches of ice accumulation. Tupelo, you're far enough north that you might see this start as snow before transitioning. The European model actually has a bullseye of heavy snow just to your north in Tennessee. Speaking of Tennessee, let's talk about what you might see. Memphis, Nashville, Knoxville, Chattanooga, Clarksville. This is where the models are really diverging, and I've got to tell you, it's making this forecast incredibly challenging. The European model has a significant snowfall event for portions of middle and eastern Tennessee. We're talking 6 to 12 inches of snow, with isolated amounts possibly exceeding 12 inches where Tennessee, Kentucky, Virginia, and West Virginia come together. Nashville, specifically on the European run, sees snow beginning Friday evening and continuing through Saturday with accumulations of 8 to 14 inches possible. But here's where I need to pump the brakes and be completely transparent with you. The GFS is considerably further south with its heaviest snow. It has the main snow axis across northern Arkansas and southern Missouri instead. For Nashville on the GFS, you're looking at more of a mixed bag, 3 to 6 inches of snow and sleet, so we have these two extremes. And the truth is probably somewhere in the middle. By Tuesday or Wednesday of this week, we should have much better clarity on which solution is going to verify. Kentucky. Let's talk about your setup. Louisville, Lexington, Bowling Green, Owensboro, Paducah. The European model loves you for snow. Louisville could see 8 to 12 inches. Lexington, you're right in that potential bullseye I mentioned, possibly 12 to 16 inches if the European solution verifies. But again, the GFS is much less impressed, showing 4 to 8 inches. We're running out of time to figure out the exact details, but the message for Kentucky is clear. Significant winter weather is likely this weekend. The question is just how much and what type. Missouri? Let's break you down. Kansas City, Street, Louis, Springfield, Columbia, Joplin. You're all going to see winter weather Friday into Saturday. Kansas City starts Friday afternoon as snow continues through Friday night. Accumulations on the European model are in the 4 to 8 inch range. Street Louis is in a really interesting position because you're right on the northern edge of the heavier precipitation. The European model shows 6 to 10 inches. Springfield, you could see more mixing, starting as snow Friday evening, possibly transitioning to sleet overnight. Columbia and Joplin, similar story, Friday evening through Saturday morning. Now let's pivot to the eastern U.S., and this is where we get into what I call the late bloomer scenario. This is the second phase of this winter storm, and it's the part that has me the most intrigued from a meteorological standpoint. Illinois. Let's start with you. Chicago, Springfield, Peoria, Rockford, Champaign. You're looking at light to moderate snow Friday into Saturday. Chicago specifically, snow begins Friday afternoon, continues through Saturday morning. The European model shows 3 to 6 inches. Not a blockbuster by Chicago standards, but enough to impact travel. The GFS is similar for Illinois, showing 4 to 7 inches for the Chicago Metro, Indiana, Indianapolis, Fort Wayne, Evansville, South Bend, Bloomington. Friday evening is when things get going for you. Indianapolis sees snow beginning around 6 p.m. Friday, continuing through Saturday afternoon. Accumulations on the European model are 4 to 8 inches. Fort Wayne, you're far enough north that you might see this linger into Saturday evening. South Bend, same deal. Evansville is on the southern fringe, so you might see some mixing with sleet. Ohio. Here's your breakdown. Columbus, Cleveland, Cincinnati, Toledo, Dayton, Akron. The models are showing Friday evening into Saturday for most of you. Columbus starts around 7 p.m. Friday, snow continuing through Saturday morning, 4 to 8 inches on the European model. Cleveland, you're in the lake effect shadow, So you might actually see enhanced snowfall on the backside of this system Sunday into Monday. Cincinnati is right on the transition zone with Kentucky, so there could be some sleet mixing in initially before going to all snow. Michigan. Let's talk about Detroit, Grand Rapids, Lansing, Ann Arbor, Friday night into Saturday for most of Michigan. Detroit sees snow beginning late Friday evening, continuing through Saturday afternoon. The European model shows 3 to 7 inches. Grand Rapids, similar timeline and amounts. This is not going to be a historic snowstorm for Michigan, but it's definitely going to be impactful for weekend travel. Wisconsin, Milwaukee, Madison, Green Bay, you're all in play for Friday night into Saturday. Milwaukee starts around 8 p.m. Friday continues through Saturday morning. The models are showing 4 to 8 inches. Madison, you're right in the sweet spot for some decent snowfall, possibly 6 to 10 inches. Green Bay, same timeline, 4 to 8 inches likely. Now here's where things get really fascinating. We need to talk about what happens along the East Coast, because this is where that late bloomer scenario comes into play. What's happening atmospherically is that we have northern stream energy diving down from Canada. This is very cold air, and it's arriving Friday into Saturday across the mid-Atlantic and southeast. At the same time, we have what meteorologists call a southern stream disturbance, some energy moving along the Gulf Coast. The question is, do these two pieces of energy phase together? If they do, we could see a significant coastal storm develop. Georgia, let's start with you. Atlanta, Augusta, Savannah, Athens, Macon, the models are in disagreement about your fate. The European model has a late developing coastal low that throws moisture back into very cold air Saturday night into Sunday morning. Atlanta could see snow Saturday night, possibly 2 to 5 inches. This would be falling with temperatures in the teens and low 20s, which is absolutely brutal cold for Atlanta. Augusta is right in the European model's bullseye, showing potential for 4 to 8 inches of snow Saturday night into Sunday. But here's the thing that I need to emphasize. The GFS doesn't develop this coastal low nearly as aggressively. It shows maybe an inch or two for northern Georgia, and that's about it. North Carolina. This is where 3 out of 3 major model runs are showing accumulating snow, so I'm paying very close attention. Charlotte, Raleigh, Greensboro, Durham, Winston-Salem, Asheville, Fayetteville. The European model has Saturday night into Sunday morning as your window. Charlotte specifically could see 4 to 8 inches of snow falling in temperatures around 15 degrees Fahrenheit. That's snow that's going to be extremely fluffy and powdery. Raleigh. The European model shows 6 to 10 inches Saturday night into Sunday. Greensboro. Similar amounts. Durham and Winston-Salem. You're in that same zone. What's wild about this setup is the snow-to-liquid ratio. When you have air temperatures this cold and you're getting moisture from a coastal system, you can see ratios of 15 to 1 or even 20 to 1 instead of the typical 10 to 1. That means every tenth of an inch of liquid precipitation could produce 1.5 to 2 inches of snow. Asheville, you're in the mountains, so you could see enhanced amounts, possibly 8 to 12 inches on the European model. Fayetteville is closer to the coast, so you're looking at 4 to 7 inches. South Carolina. Let's talk about Columbia, Charleston, Greenville, Spartanburg, Rock Hill. The European model is very aggressive with snow for the Midlands and upstate. Columbia could see 3 to 6 inches Saturday night into Sunday. This would be falling in temperatures around 18 degrees. Charleston, you're close enough to the coast that the GFS keeps you mostly dry, but the European model shows 1 to 3 inches of snow, which would be remarkable for the Charleston area. Greenville and Spartanburg, you're in the upstate, so the European model shows 5 to 9 inches. Rock Hill, similar to Columbia, 3 to 6 inches. Virginia, Richmond, Virginia Beach, Norfolk, Roanoke, Lynchburg, Charlottesville. The models are showing Saturday night into Sunday as your time frame. Richmond, on the European model, sees 6 to 10 inches of snow. Virginia Beach and Norfolk, you're right on the coast, so this is highly dependent on the exact track of the low pressure. If it tracks 50 miles further east, you get mostly rain. If it tracks 50 miles further west, you could see significant snow. The European model currently has 4 to 8 inches for the Hampton Roads area. Roanoke and Lynchburg are further inland and at higher elevation, so the European model shows 8 to 12 inches. Charlottesville, 6 to 10 inches. West Virginia, Charleston, Huntington, Morgantown, Parkersburg, you're all looking at significant snow potential Saturday night into Sunday. Charleston could see 8 to 12 inches. Huntington, similar amounts. Morgantown is far enough north that you might see this continue into Sunday afternoon. The European model has a jackpot zone where West Virginia, Kentucky, and Tennessee come together with amounts exceeding 12 inches, possibly approaching 16 to 20 inches in the highest elevations. Maryland and D.C. Metro. Let's talk about Baltimore, Frederick, Hagerstown, Washington, D.C., Arlington, Alexandria. Saturday night into Sunday is your window. Baltimore, on the European model, sees 6 to 10 inches of snow in very cold air. Frederick and Hagerstown are further from the coast and at higher elevation, so 8 to 12 inches is possible. Washington, D.C., this is a tricky forecast because you're right in that zone where 50 miles makes a huge difference. The European model currently shows 6 to 10 inches for the district. Arlington and Alexandria, same forecast. Delaware, Wilmington, Dover. Saturday night into Sunday. Wilmington could see 4 to 8 inches on the European model. Dover is closer to the bay, so there might be some mixing issues. But the cold air is so entrenched that I think you stay mostly snow. Pennsylvania, Philadelphia, Pittsburgh, Harrisburg, Allentown, Erie, Scranton. Let's break this down. Philadelphia is right on the coast, so you're highly sensitive to track. The European model shows 5 to 9 inches Saturday night into Sunday. Pittsburgh is on the western side of the state, so you actually get the first wave of snow Friday night into Saturday, 3 to 6 inches, and then possibly additional snow Sunday if the coastal low tracks far enough west. Harrisburg is in central PA. The European model shows 6 to 10 inches Saturday night into Sunday. Allentown, 7 to 11 inches. Erie, you're up on the lake, so you get lake effect enhancement after the main system, possibly 8 to 14 inches total. Scranton, 6 to 10 inches. New Jersey, Newark, Jersey City, Trenton, Atlantic City, Saturday night into Sunday. Newark and Jersey City are in the urban corridor. The European model shows 5 to 9 inches. Trenton is further south, 6 to 10 inches. Atlantic City is right on the coast, so 3 to 7 inches with potential for some mixing. New York, let's talk about New York City, Buffalo, Rochester, Syracuse, Albany. New York City is the forecast I'm least confident about right now because you're right on that rain-snow line. The European model currently shows 4 to 8 inches Saturday night into Sunday, but a 50-mile shift in the low track completely changes that forecast. Buffalo is on the western side of the state, so you get the first wave Friday night, then lake effect Sunday and Monday, possibly 8 to 14 inches total. Rochester, similar scenario. Syracuse, you're in the snow belt, so the European model shows 8 to 12 inches from the main system plus additional lake effect. Albany is further north, 6 to 10 inches Saturday night into Sunday. Connecticut, Hartford, New Haven, Stamford, Bridgeport, Saturday night into Sunday for all of you. Hartford could see 5 to 9 inches on the European model. New Haven, Stamford, and Bridgeport are all closer to the coast, so 4 to 8 inches with some uncertainty about mixing. Massachusetts, Boston, Worcester, Springfield, Cambridge. The European model has Saturday night into Sunday as your time frame. Boston could see 4 to 8 inches. Worcester is further inland and at higher elevation, so 6 to 10 inches. Springfield, 5 to 9 inches. Cambridge, same as Boston. Rhode Island, Providence, Saturday night into Sunday, 4 to 8 inches on the European model. New Hampshire, Manchester, Nashua. You're looking at Saturday night into Sunday. The European model shows 5 to 9 inches. Vermont, Burlington. Saturday night into Sunday, 6 to 10 inches on the European model with higher amounts in the mountains. Maine, Portland, Lewiston, Bangor, Saturday night into Sunday, extending into Monday for northern areas. Portland could see 6 to 10 inches. Lewiston, similar. Bangor is further north, so this could be a longer duration event, possibly 8 to 14 inches. Now let's geek out about the atmospheric dynamics, because this is what makes this setup so fascinating. We're dealing with what meteorologists call a Miller B track for the first part of the system. That means low pressure tracking up the Tennessee Valley, bringing warm air to the surface across Alabama and Mississippi, but the cold air is locked in place east of the Appalachians. This creates what we call cold air damming. It's like the mountains act as a dam, preventing the warm air from moving eastward. So you end up with this situation where it's raining in Birmingham, but it's snowing in Charlotte, even though they're at similar latitudes. The second part of this system, the late bloomer, is even more interesting. We have very strong northern stream energy diving down from Canada. This is a piece of the polar vortex that's been dislodged and is dropping southward. At the same time, we have southern stream energy moving along the Gulf Coast. The European model shows these two pieces of energy phasing together just off the Carolina coast Saturday night. When these two pieces of energy combine, the low-pressure system intensifies rapidly. Meteorologists call this bombing out. The pressure drops very quickly, the winds increase, and you get very heavy snowfall rates. What's particularly notable about the European model's solution is the snow-to-liquid ratios. We're talking about snow falling in air temperatures of 10 to 20 degrees Fahrenheit. At those temperatures, the snow is extremely dry and fluffy. Every tenth of an inch of liquid could produce 1.5 to 2 inches of snow. That's why the European model is showing such impressive snowfall totals for portions of the Carolinas, Virginia, and West Virginia. The GFS doesn't phase the energy quite as effectively, which is why it's showing lower amounts. There's also a question about something called the dry slot. Sometimes with these coastal systems, you get a gap in the precipitation where dry air wraps around from the northwest and temporarily shuts off the snow. The European model doesn't show much of a dry slot, which is why the snowfall is more continuous. The GFS has a more pronounced dry slot, which cuts down on accumulations. Another factor to watch is the deformation zone. This is where the heaviest snow bands typically set up in these coastal storms. It's an area where winds are coming together from different directions, forcing air to rise very rapidly. The European model has the deformation zone right over the southern Appalachians and the Carolinas, which is why those areas see such heavy snow. The GFS has the deformation zone further out to sea. I also need to talk about the cold air aspect of this pattern because it's absolutely remarkable. We're not just talking about cold for a day or two. This is a sustained Arctic outbreak that's going to last at least a week, possibly longer. The pattern is being driven by what's called high latitude blocking. There's a big area of high pressure over Greenland and the North Atlantic that's preventing the normal west-to-east flow of weather systems. Instead, it's forcing the jet stream to buckle southward over North America, allowing Arctic air to spill down from Canada. When I look at the temperature forecast for the coming week, it's just brutally cold. Areas of Tennessee and Kentucky that just dealt with a catastrophic ice storm are going to see low temperatures in the single digits above zero Monday morning. Some areas could even drop below zero, and the high temperatures all week are not going to get above freezing for many locations. That means any ice that accumulated from the previous storm is going to stay on trees and power lines all week. That's extremely dangerous for the power grid. By Tuesday morning, we're looking at temperatures in the single digits as far south as northern Mississippi and Alabama. Some areas in the Appalachian valleys could see below zero temperatures. This is combined with snow on the ground in many areas, which makes it even more dangerous. Wednesday morning looks like one of the coldest mornings of the entire outbreak, with below zero temperatures extending well into the mid-Atlantic. There's also a reinforcing shot of cold air arriving Thursday into Friday, which is actually going to make the second wave of winter weather even colder than the first. This is why the European model is showing snow falling in temperatures around 15 degrees in places like Charlotte and Atlanta. That's extraordinarily cold for those cities. The pattern doesn't look like it's going to break until we get into the second week of February. In fact, some of the extended range models are showing an even stronger signal for winter weather around February 8th through 10th. So if you're not a fan of winter, I've got to tell you, this is not the pattern you want to see. We're looking at potentially 3 or 4 weeks of sustained cold and multiple winter storm threats. Now let's talk about the snowfall maps, because this is where we can really see the differences between the models. The European model has the main axis of heavy snow, extending from southern Illinois through Indiana, Ohio, and then a secondary axis through Kentucky, Tennessee, Virginia, West Virginia, and into the Carolinas. The bullseye, the area of maximum accumulation, is right where those four states come together. We're talking about 12 to 18 inches possible, with isolated amounts exceeding 20 inches in the highest elevations. The GFS is considerably further south with its primary snow axis. It has the heaviest snow across Arkansas, northern Mississippi, and Tennessee. For the coastal system, the GFS is less aggressive than the European model, showing 6 to 10 inches for most of the Carolinas, instead of the 8 to 14 inches the European shows. The Euro ensemble mean, which takes the average of 51 different model runs, is showing a pretty strong signal for snow across the Carolinas and southern Appalachians. That's a bullseye of 4 to 8 inches extending from Columbia, South Carolina through Charlotte and into the Greensboro and Raleigh areas. The fact that the ensemble mean is showing this gives me more confidence that we're going to see accumulating snow in that region. The GFS ensemble is also showing a signal, though it's a bit more focused on the immediate coastal areas. It has a 3 to 6 inch mean stretching along the Carolina coast up into the Delmarva Peninsula, so both ensemble systems are seeing something, which tells me there's a legitimate signal here. The question is just the magnitude. One thing I want to emphasize is the timing uncertainty. The European model has the coastal low developing Saturday night into Sunday morning. The Euro AI, which is the artificial intelligence enhanced version, actually has this 1 day later, Sunday night into Monday. That 24-hour difference is huge for people trying to plan their weekend. If the Euro AI is right, then Saturday might actually be relatively quiet, with the snow holding off until Sunday night. But if the standard European model is right, Saturday night is when things get going. Here's what we know with high confidence at this point. First, it's going to be very cold. That's a done deal. The Arctic air is locked and loaded, and it's going to be brutally cold across the central and eastern U.S. for at least the next 7 to 10 days. Second, there is winter weather potential for a large portion of the country this weekend. The exact location and magnitude is still uncertain, but the signal is there. Third, this is a multi-phase event. We're going to have winter weather Friday into Saturday for the central U.S., then potentially a separate coastal storm Saturday night into Sunday for the East Coast. What we don't know yet is the exact precipitation types for the transition zones. Cities like Little Rock, Memphis, Louisville, these are all areas where the difference between snow, sleet, and freezing rain is going to come down to just a few degrees of temperature. We also don't know the exact track of the coastal low, which is going to determine who sees heavy snow and who stays mostly dry along the East Coast. I'm not fully convinced by either model solution at this point. I think the European model might be a bit too aggressive with the coastal storm, and I think the GFS might be underplaying it slightly. My gut feeling is that the truth is going to be somewhere in between. We'll probably see 4 to 8 inches of snow for much of the Carolinas instead of the 8 to 14 the European shows, but more than the 2 to 4 the GFS shows. This could easily shift northward if the low tracks 50 miles further west, which would bring heavy snow into Philadelphia, New York City, and Boston instead of the Carolinas. Or it could shift southward and offshore, which would leave most areas with much lighter amounts. These coastal storms are notoriously difficult to forecast more than 48 hours in advance. One other thing I want to mention is the freezing rain potential for the first wave. The models are showing some significant ice accumulation potential for portions of Texas, Oklahoma, Arkansas, Louisiana, and Mississippi. We're talking about quarter to half-inch amounts in some areas, which is enough to cause catastrophic damage to trees and power lines. Areas like Nashville, Memphis, Louisville, that just dealt with a major ice storm, are going to see additional winter weather this weekend. It might not be ice this time, it might be heavy snow instead, but either way, it's going to compound the problems from the previous storm. The Weather Prediction Center has already posted winter weather outlook areas showing 10 to 30% probability of significant snow or sleet accumulation. That 10 to 30% chance corresponds to 2 to 12 inches of snow or sleet. So they're already seeing enough of a signal to start highlighting areas of concern. I expect by Monday or Tuesday, we'll start seeing winter storm watches posted for portions of the Southeast and Mid-Atlantic for the Saturday night into Sunday timeframe. So to recap what we've covered so far, we have a complex, multi-phase winter storm approaching. Phase 1 affects the central U.S. Friday into Saturday with snow, sleet, and freezing rain from Texas through the Tennessee Valley. Phase 2 is a potential coastal storm Saturday night into Sunday affecting the southeast and possibly the mid-Atlantic and northeast. The models are showing different solutions, with the European more aggressive than the GFS. We have very cold air locked in place for an extended period, and we have uncertainty about exact precipitation types and amounts for many locations. We're running out of time to figure out the exact details, but here's what I would recommend. If you're in the central U.S. from Texas through Tennessee, start preparing now for winter weather Friday into Saturday. If you're in the Carolinas, Virginia, or the Mid-Atlantic, monitor forecasts closely throughout the week for a potential significant snow event Saturday night into Sunday. And regardless of where you are in the eastern half of the country, prepare for an extended period of very cold weather. I'll be back tomorrow morning with fresh model data, and we'll see which solution the models are trending toward. Are they coming together on a consensus, or are they diverging even further? That's going to tell us a lot. There's also another potential winter storm signal for the following weekend, around February 7th or 8th, that we need to start watching. The extended range models are showing that one could be even more significant than this upcoming system. If you'd like a specific forecast for your city, leave it in the comments and I'll answer individually as time allows. I know this was a lot of information to digest, but I wanted to give you the complete picture of what we're dealing with. This is a fascinating setup from a meteorological standpoint, and it has the potential to impact a huge portion of the country. The key takeaway is this: winter is not over. In fact, we might be entering the most active and coldest period of the entire winter season. If you found this breakdown helpful, subscribing to the channel would be appreciated. I'll continue to provide detailed analysis as this system evolves throughout the week. Stay safe, stay warm, and we'll talk tomorrow morning.